Thank you everyone for joining us. It is a pleasure to have Brad here. Brad runs a bunch of ML engineering at Martian, and we are lucky to have him with us just to explain and help us understand what judges and routing really is and what it means in this context of the hackathon and what everyone's working on now. So take it away, Brad, and excited to hear more about the process.
Thank you, Espen, for a great introduction here. So I'm very excited to talk to you all today about judging and routing, how they play together, and how you can kind of get your hands dirty this weekend and make use of what we have here at Martian and kind of build on top of that. So let's just define a few. Sure thing. Yes. Again, I'll zoom in. Hopefully this is now. This is very clear. So yeah, and if you do have questions, feel free to kind of interrupt me. I know people don't have permission to speak, but if you kind of send a message in the chat, I'll be checking over periodically and can kind of answer questions kind of as you have them. So what I'm going to discuss at the start is these. There's also a request to speak, I see. So wonderful. These concepts of judges and routers. And I think it's really important to understand judges first. And what are judges? So, you'll be probably familiar with LLM as judges off the bat. And what is this? Let's define that interface. So a judge, in how we define it, is something that takes as input a request, a chat completion request, and a completion response. So it takes those two objects and it outputs a judgment, which is an object here that consists of a score, which is some floating point number, and a reason. So this is a rationale, so a string rationale detailing why the given score was made. So for instance, if you have a judge that is here to assess truthfulness, if you have a request that comes in that says, who is the President of the United States, and the chat response is Philip Schofield, that's clearly incorrect. And so your score, the judge should give a low score, and the reason behind this will be quite trivial. It's like, Philip Schofield, no, is a television presenter. He is not the President of the United States. That is XYZ. So that is the interface behind the judge. Now, this doesn't restrict you, if you think about it, to just having an LLM as a judge under the hood. So in the most basic form, that can be an LLM judge. This is what we call the rubric judge. But more broadly, it can be a complex kind of composition of other judges. So we have built in Martian a DSL, in short, kind of a programming language around judges. So the core component of this is kind of that LLM as judge. It is the rubric judge. And in the rubric judge, you kind of define your rubric, your string. So my rubric might be for the judge. The answer is truthful. The response to the question adheres to the following criteria. It is truthful, it is concise, it is all these nice properties you desire, but also the response, from the LLM only is from this kind of dictionary of or vocabulary of terms. You can define this however you like. But it's quite often hard to capture all of that into a single rubric. Often there is kind of logic you might want to compose together. And that is where kind of the DSL really comes into its own. And so what we enable, if we think about how you can kind of compose judges together, you can sum them. So if you've got one judge that is great at assessing truthfulness in your given context, another judge that is great for assessing kind of conciseness, and another one that's great for assessing clarity, you could sum those together. And this will just, if you have the same input, which is the request and the response, and your output now, the score will be the sum of those individual subjudges, and the reason will be the concatenation. So that's kind of a sum operation. You may want to do a max operation to kind of take the best scoring judge, or a min operation. So if you care about, just looking at the worst performing judge, and that is the one that we should kind of surface to the top. And case judging allows kind of conditional logic. If this judge exceeds this score, then do X, Y, Z. And so what this enables us to do is define judges with a level of detail and complexity that is kind of required to achieve high quality. I'm going to switch over now so I can see the chat to see if there's any questions here, and address them before I move on. So, at a part, the concept justifies who wins the hackathon. Yes. In a way, building judges is a very hard challenge. This is why we have this rich framework. And, if you have great ways of developing a judge, definitely goes a long way. So, question for later. There's often pretty low, but possibly unacceptable failure rate on simple prompt-based judge. How does DSL improve the verifiability and reliability? So make sure it's often failure rate. Okay, when you say about failure rate here, can I understand exactly what you mean? Do you mean failure in the sense the judge gives an incorrect score on a given request?
Mostly that the judge gives a somewhat either an incorrect score, like one that is misguided through too simple prompting or something like this, or that it simply goes out of distribution compared to the boundaries. So, for example, if you tell ChatGPT, hey, rate this essay on a grade scale from 1 to 10, and then it gives it 15 or something. This can happen, right? This is not an
Yes.
not
Yeah,
correct.
it's a good question. So I think, there's two pieces I'll answer to that in kind of reverse order. So to the latter piece, ensuring a valid output. So when you define, with the Martian SDK, like your rubric string, there's a few things that happen under the hood, which are appended and prepended to the prompt and kind of formatted that rubric in the right way, such that we tell the LM to output, in HTML tags, the judgment, so that the judgment, the reason string, and the score, and we can kind of give some examples in there as well. The LLM output can of course do whatever it likes. So we will parse for those HTML tags, and if they exist, pull them out. If they don't exist, then we can just populate them as kind of with default values, which makes sense. To your question specifically on what happens if the range is 0 to 1, but it outputs a 5. So when you define that judge, you can also specify as the rubric string, but also the min score and the max score. And so this will bound that output. So if it does output a 15, it'll cap it to a 1. So there is some kind of basic engineering work that can increase the reliability of how well these judges perform. So that is kind of a very important piece. And then I think the first part of the question, which is the judge can quite often be it can be incorrect. And I think this is why it's good to in a way like build up a bit more kind of diversity. So for assessing truthfulness, for instance, there's maybe one or two, three or four different methods that you'd want to implement here to really assess if this answer is truthful. And if any one of them fail, then you should give a low score. So what you could do is you could write 4 rubric judges, which are getting the LLM to assess truthfulness, but with different methodologies. And then you would take a min score. So you kind of combine them into a min score judge. And that's a very simple interface. Again, min score judge will take this list of judges in, and it will then output the minimum score. So you have to pass all 4 measures of truthfulness in order to get a good score. And your reasoning again would be concatenated together. Does that kind of answer your question? Yes, wonderful. I see a question, another one. So, is the judge always ever judging according to Martian's established factors of importance, or does it factor in measures of effectiveness from the user's perspective? So, the rubric is written by the user. So that really defines what the judge is assessing. And you could write a judge to assess for, you may want actually the LM responses to be not truthful. You may want it to output only kind of, fake things, right? You could write that rubric to do so. So it's not according to kind of Martian's kind of internal kind of rubrics that are written that the judge is assessing against. All kind of Martian has it is that kind of framework to let you easily compose judges together and write these rubrics, and kind of the boilerplate code to ensure that you're going to get your nice formatted kind of floating point numbers out and your kind of judgment strings. And so that it shouldn't really affect the actual judgment, if that makes sense. Yeah, so rubric strings. Yep. Are judges also put under evaluation, perhaps against human evaluation? This is a really great question. So anybody who has worked with annotation before human annotation will know it's very noisy. And there's a bunch of different metrics you can look at. So if you haven't done this before, look at inter-annotated agreement. There's Kappa's Cohen, Flea's Kappa. There's a number of metrics that can help you assess inter-annotator agreement. One of the great things about the judge is this is more consistent than a bunch of annotators. So what you want is you want high agreement between the annotators and the judge, even though sometimes there's like disagreement between annotators, but you want kind of high agreement between the judge and the annotators. So this is kind of really what you're assessing against. And then to your question on kind of, how can you use this? We do have a judge type. It's not shown here, called the exact match judge. And so if you have a gold standard kind of response written by a human, then that can be a judge that will assess how good the response is compared to that gold standard response. So this is not a judge you can use at inference time, but it is a judge you can make use of at training time. And that's kind of one way you can kind of include human annotations to kind of improve kind of judge scores. But really, you're kind of looking to you'd be looking to assess high agreement between that gold kind of match judge and the inference time judge you kind of create. And if these have high agreement, then you're kind of in a good spot and you can scale. Left the room for 2 minutes and okay, wonderful. That answered the question. Okay, I think that was most of the questions on judges. If there is one I missed, please just repost it in the chat, and I can make sure I answer that. Okay, so now we've got a judge, and of course, you'll iterate on this with a as a user until you get something you're happy with. Once you've got something you're happy with, you're in a very good position because you can now basically scalably annotate and assess and evaluate data. And this kind of brings me on to kind of routers. And what is a router? And I'll talk about what kind of a router is in Martian and how we define it. So a router is something that, given a chat completion request, so it just takes the request, it will behave exactly like any other LLM. You can treat this as a black box, like an LLM. You treat an LLM like a black box. It has exactly the same interface as as OpenAI models do. So you take as input chat completion request, and you output a chat completion response. Under the hood, the only thing that is different is the router has access to multiple different LLMs, And so it can leverage those different LLMs to generate you a better response. And there's a really great analogy, I think, to help kind of drill this point home, because I think often when people think about routers, they first think about, oh, I can, Gemini is very good at coding, so I can just send coding problems to Gemini, and maybe ChatGPT is very good at, chat conversations, so I'll send those requests here, and if I can book it at that high level, you can do that. But your best performance gains come from getting really down to the low level details of, for this specific prompt, which can be quite niche within a specific sector, based upon the features we extract, this model is going to perform better. So the analogy I like to think about is, if you imagine two students taking a test, an examination, if the first student in the test gets, 7 out of 10 questions right, and it's the first 7 questions, and your second student gets the final 3 questions right, but the first 7 wrong, you can actually get 100% in this test if you just know which question to route to which student. The first 7 questions to the first student, the final 3 to the second student, 100% job done. So what that really means is, like, for an LLM router, you can get state-of-the-art performance. You can get better than your best reasoning model by leveraging some models that on average may perform better. They may be that 30% student, but they just happen to perform better, on specific prompts that, you care about. And the more models you have, there is kind of more of this overlap, and this kind of the gaps between them you can exploit and perform very, very well at. So that's really like the high level concept of a router, is if you know well how you can understand how the LLMs perform on individual prompts within a use case, you can get really great performance. I'll just again pause briefly now to check for questions. Okay. Yes, I think there's some good comments coming in here. And a question. One thing I'm super excited about with routers is that we're able to direct it towards specialized models for specific tasks, and we avoid errors that general models are prone to. Do you see routers also as routing, e.g., a lawyer AI or medical AI over just Claude or ChatGPT? You just reread that again to make sure I understood. If I repeat back, I think the question is here, do I see routers as being able to leverage more of these specialized, domain-specific models and task-specific models that general models are prone to? Sorry, that was more your statement. And then also routing to... Yeah, so I think I understand this question. Yeah, I definitely do see that being the case. And what I would say is, right, even within, say, lawyer AI, if you imagine you're solving a law question, and that's a law question which is in Hebrew, right? You may have a great lawyer AI, but it's only good in English. Maybe you've got a Hebrew law question that it turns out, for whatever reason, on Llama's training data, they're pretty good at it. That's what you want to route to. Or kind of in the future, you already see this right now, proliferation of Hugging Face. Lots of specific models. Like when a company wants to make a model and publicize that for a specific language or a specific use case, you want to know when that performs well and when it doesn't. So there was 100% the case is if you have enough data and you can leverage that data, you can 100% make use of your specialized medical AI, but you have to know when to use it and when not to use it, because if you're in a foreign language, it may be worse performing than something else. So you've got to be careful, and you've got to basically just churn through that data and learn what's best to do here. Okay, good question here. What sources of vulnerability for jailbreaking for the router component of the API? This is very interesting, and it really much depends upon the routing methodology. And routing is, I'd say, there's we kind of bucket routers into a couple of different areas. There's one which is more classical machine learning based, and think more, you can extract all your standard NLP features, whether that's the basic ones such as TF-IDF, more complex, you got LDA, you've got sort of different topic modeling, you've got embedding features you can do. There's a lot of NLP kind of feature-based extraction you can do, and you can train a model, and there's all different model classes you can have. So there's a question on like how does jailbreaking work in that scenario? That I'd say is a little bit more robust than if your router, if you had a purely LLM-based router. If you had a purely LLM-based router, then an obvious jailbreak might be, if I'm wanting to, well, there's a question on what is the motivation here. If you're wanting to affect the routing to kind of make a worse performance, you could imagine, telling the LLM to exhibit certain behaviors under kind of test time performance, if you've got an LLM as a judge, used in the routing process. But it really depends on the routing method. And yeah, it's I think it's a really great question. So yeah, I'd love to have maybe a bit more discussion on that, but I don't think I have necessarily all the answers, and it's not something I've managed to have a chance to think about too much just yet. Are soft routers also possible in this context? Perhaps a merged response across multiple models perform better. Oh, okay, this is a really interesting question. So yeah, why not, right? This is definitely possible. However, right now Martian doesn't do this. It's more from a transparency perspective. We don't do this. It's a clean product to just say, when you send your request in, we'll return back your check completion response, but also kind of the model that was used. And it's very clear, kind of a very clear value prop that this is just adding value. And I'm going to come on to kind of how cost and quality play into this in a second. It's a very clear kind of value prop. There is, you could argue, a bigger value add again to get more into the modeling piece. It's not a space that we're currently playing, but I think it's one which is very exciting and definitely something you can explore and do more with. Okay. What are the key behaviors you'd love to understand within the neural network of the router? What are the...
Maybe I'll also just jump on the stage now.
Yeah.
We have a lot of great comments, and then
Yeah.
we've got you reading them here, so that's great. I'll break the chain a bit. But the question here is basically, what are you really excited about seeing from participants of this hackathon, figuring out about your routers, right? Like about these algorithms you use, about like the what is the mechanistic interpretability here that we can really make a difference for reliability, verifiability, jailbreak ability, whatever, in your eyes.
Yeah. Okay, there's a few things, and I'll do this more broadly on judging and routers and well, because I think a few of them apply to kind of both. LLMs have a stochastic nature to them. So if you've got an LLM as judge, if you run the same request 1 time, 2 times, 3 times, you may get different responses. We care a lot about having measuring the variance of an LLM judge. Like if it's a high variance judge, this is not a good judge. This is a very bad judge. Again, with routers, right? If you've got a high variance router. Now, with our routing capability, I'm going to get into a little bit more details here because I think this is a little bit interesting. We build in kind of some natural kind of coin flipping. And this is intentional because if you imagine a prompt, let me come back to this question because I want to get into some details, and I think it's going to be really great to kind of explain my answer here. So, how do you kind of measure the quality of a router? Now, if you imagine for a given use case, right, how do you measure the quality of an LLM? Well, if we've got a great judge, this is wonderful. We're going to literally have a score here we can use to assess the quality of response. So we can run for a given data set that across however many LMs, 10, 12, 50 LMs, and we can plot them on a graph of quality versus cost. And this will be the average kind of quality from the judge for the given data set, and the cost will be the average cost of the data set. Bear in mind you get charged both an input token and output token. An output token costs some more. So, for especially chatty LLM, that for the same price per token model, if it's chatty versus not chatty, the chatty one will be more expensive in its responses. So you can plot all of your LMs on this curve, right? On this plane of quality versus cost. And then your router is going to be a curve up and to the left of that, which can intelligently select between models. And what I'm going to do now is I'm going to actually get you up a plot. So give me 1 second. And I think it's going to be easier just to see this. So 1 second as I get this up. Okay, so I'll just have to put this into the right tab. Hopefully you can still see. Okay, can you all now see router curve? I believe you can, because I can see what you guys can see. And let me make this zoom in a little bit bigger. Apologies, the labels now overlap. What you can see here is a plot of kind of quality versus cost. And this is individual LLM performance. And these are kind of average quality and cost. And then this router is kind of up and to the left. And so this router can, of course, achieve higher quality by leveraging different LLMs. But you can set an operating point on this curve. And, based on the modeling technique we have under the hood, in this specific router, we get discrete points, which are kind of under the hood, they are actually different models. And then if you want to get an operating point in between them, you kind of flip a coin, and based upon where you put the point, you can bias yourself to one versus the other. Now, what that kind of means in practice is, if I set, an operating point over here, I'm going to be making use of, the deep reasoning models kind of, whenever it kind of remotely makes sense to. If I set a cheaper operating point, what that means is, for the prompts that come in that still require a deep reasoning model, we're still going to be, using that model. But for the prompts where the model is like 50% sure on, does it need this deep reasoning model, or can we get away with a cheaper one? If you set a cheaper operating point, we'll bias towards picking the cheaper model. So that's really kind of what's kind of great about a router, is you can have set your average kind of cost you want to be at, which, will be an average quality. And then we can, under the hood, kind of optimize to pick what makes the most sense. Now, if I switch back actually to your question, which I might have to scroll up a little bit. Yeah, so your question was on what would be a good thing to focus on from the Mac interp side and kind of help us understand what's going on. And I mentioned, judges, of course, we care about, judge variance a lot. With routers, naturally, we expect some variance. We do have some coin flipping. However, what we want is still for a given operating point, that average that you set. So when you specify the cost constraint or the quality constraint in the API, do we actually achieve that, or do we not achieve that? That's important. Something important for us to know and understand why and why not. For out of data distribution shifts, right? Detecting that is incredibly important for, again, judges and routers. And it could be at different levels that you get, you can handle kind of your generalization differently, and you get out of distribution. So, again, that's another big area that we care about and understanding. Does that answer your question in a little bit more detail?
Yeah, I think so. There's a sense to which, so from a part researcher side, of course, like a lot of what we work on is this safety question and security. And so you could say that
Yeah.
okay, we route towards something that is more verifiable or something, and you have a judge that says, oh, it's more verifiable. Something I'm also noting here, which I personally am excited about, also as I wrote, is this point about how the natural design of routers and the natural design of what you're explaining here with the graph is something that will, optimally, I would be using the cheapest model that gets the maximum performance. And then that cheapest model, because it gets the maximum performance, or because it is the cheapest, it is also the smallest uh, viable model for this task, which means that you end up with this higher specialization, which means I, as a company who really want this to work instead of not work,
Yeah.
ends up actually being able to both save money and have much higher verifiability. There's then two questions in there that I think are quite fascinating. One is whether you see ever that cheaper models are just better, uh, if the graph does a camel hump, or if it always does this shape that you see now, the power law, over cost. Um, on specific tasks, of course, on specific judged routing tasks. And then separately, whether it's something where you actually provide these internals as well of like how we can look into this, how we can look into um, whether this happens across, if I run it, if I'm a company running on the Martian platform, then whether I can actually check these separate models for, oh, okay, this is a more specialized model. I should be able to trust it a bit more, or be able to like do some post-hoc verification or something like this. Yeah. And so there's like two questions in there of how much access do I have to this? How much do you do this now? And what hackathon participants could be doing quite a bit with. And then the
Mm,
second is whether cheap models have this camel hump on your graph here.
good question. Okay, to your first question on what you can kind of have access to, we kind of thought a bit about this actually before the hackathon on like, how we can how Martian's best going to play to help Mech and Terp. So all that's kind of available by the SDK and the API, right? Is you can, at most you can get, your logits at the end, which is supported by APIs. Because, if you're accessing OpenAI GPT 4.1, we don't get access to much information. So that's kind of all you've got available to you. And then that also is the same for if you're prompting out to a model hosted, behind the scenes on Together AI or on Lambda Labs, wherever it might be, even if it's an open source model, it's only what those providers will have access to. The question then is like, I'll just extend a little bit further, like how best you kind of utilize kind of Martian even during this hackathon to kind of do some interesting research, because we care a lot about Mech and Turb, right? That's why we're kind of doing this hackathon with you all. And so you can kind of just use Martian as if you want, kind of an LLM gateway. You can use the whole judging framework. So you can, take any model you want off Hugging Face, right? Do experimentation and figure things out there, and have the judging framework kind of run by Martian to kind of help, accelerate out your analysis. Or if you want to just prompt out, you've got some free credits, use this as a gateway. So it's very challenging to expose the level of internal details, whether you want activations at every single layer to expose that. We don't currently support that. It would be, I think, interesting going forward if we can support that for open source models, and it's definitely something we can look at. It's just not there today, sadly. So that would be kind of my recommendation to kind of your first question. Um, your Sorry, remind me again the second question.
Yeah, so the second question is whether you ever see a camel hump there. And thanks for the answer to the first question. And always
Yeah.
more good questions there. But if you have more on the talk as well, I'll let you get to it right after.
So yeah, it's really great questions. So do we expect, so the camel hump. So what I showed you was actually a pretty nice looking curve, and you would expect kind of a bit of, slight more kind of variance in your kind of root curve. What I would say though is like there were small models on that plot. So what you were looking at was a plot of the router, and individual LLMs, small and large, were kind of shown there, and the router will kind of leverage whatever it kind of makes sense to do. So when kind of ask the question, do you still kind of see this curve? Absolutely. And the way kind of that router specifically, again, there's lots of routing kind of like modeling techniques you can do. You saw was kind of like lines between individual points. So we kind of had trained models for each of those points. And there are a bunch of trained models that didn't lie on that kind of frontier, which ignore them. Right? We just care about the ones that are going to lie on this frontier and kind of will be kind of the optimal kind of performance and generalize well to the test set. So kind of there's if you optimize too much on the train set, right, you can get a nice beautiful curve, but if you pick high variance point, it's not going to translate well to your test set. So you want to pick kind of these low variance close to these Pareto frontier points, and that you can kind of construct a router out of. There are other routing methods, like there's open source papers like Carrot, for instance, if you've not read that one, where they have a continuous curve which you have this parameter you can kind of vary, kind of get kind of this trade-off between cost and quality. We actually find it's better to just have individual points kind of executed and then combine that with other methods. There's there's lots in the kind of the routing kind of framework. A bad router should really be kind of at worst just the individual LMs, right? Because if you're worse, like there's just no value at all. Like your default can just be route to this LLM and then this LLM on this frontier and this LLM. So your kind of zero router is just a line between the kind of frontier models on this cost quality point. That's your most basic router, requires no modeling techniques. It just requires you to do the analysis on the models for your given use case, and then you draw them up. So you'll always have something, if you put in the work, like which is, lets you kind of get a frontier. And then if you put a bit more work in, you should be able to move up and to the left a bit. So yeah, in short, like you should always kind of see this kind of, nice kind of arc.
Nice. And I guess the question as well here, the arc itself makes a lot of sense. The question is if you see, and throw away all the bad models, throw away the ones that aren't at the Pareto frontier, the like combination of best cost efficiency, that curve. And then, but do you ever see this curve? So now it looks like this. Do you ever see it go like this, where there's actually a cheap model that outperforms Claude? Yeah, so you have some Hugging Face specialized for law, or specialized for truthfulness, or specialized for cybersec, and you're like, oh, this is like what we're judging here, and you do like you figure out that it outperforms and is cheaper, and then if you go to Claude, it's more expensive and it's less performant.
I see. So what I maybe didn't quite show you enough on the picture is like there's an end to that curve. So if, for instance, you have this what you describe as a camel hump, you just stop here, and then you kind of that is kind of the best point. And there is so like our router, like if you pick an operating point outside of this, I'm trying to remember if Josh on the call, I can't remember if we throw an error and say you should pick a lower one. I think if you pick a higher cost point than what we think we can actually achieve, we just default to that. And so I can check those engineering details. But the point is, if you have that, what you have is kind of a curve, and it just stops at this point, and there's nothing kind of after that. So that would be your kind of optimum, if that makes sense.
Yeah, interesting.
That you would why would you ever bring it back down? Because that is not that's not a frontier point.
Yeah, okay, makes sense. So you end up actually just like cutting the if there is a fantastic cheap model, you just cut the curve, and so you never have to.
Exactly.
Yeah, because it makes a lot of sense with the Pareto frontier.
Exactly. But often is the case, like having more models, is probably gonna help you out. So that could be very good for one specific domain. But if you've got, if that is your only kind of, if all the prompts I've just not seen this in any use case where like one model, excels. There's no single model that can give you a single better response for one of your prompts in your data set. I've just not seen that to be the case. If you've got a very, very, very narrow scope and a very specialized model, that may be the case. But in general, like, problem scopes are somewhat broad, and diversity models definitely helps here, and more the better. Okay. I'll just check to see if there's any more questions in the chat from some other people before I go on. So, could I expand on what I think on task decomposition routing, i.e., when we use different LMs to execute different subtasks in parallel for single? Okay, yeah, this is again a really interesting question. So I'll just kind of repeat it back for anybody who couldn't read my mind, or didn't read the chat. The question here is, right now there's a paper, I think this is specifically referring to an interesting paper from Google, where they had Gemini Flash and Gemini Ultra, I believe, and they had some really difficult problem, and they had, Gemini Flash is very cheap. This can do a quick search of kind of the space of solutions, and when it finds something a bit interesting, switch that over to Gemini Ultra. Gemini Ultra can then do can really evaluate if this actually merits kind of further exploration and figures things out more broadly, and kind of these two kind of work together. This kind of like this kind of very fast but not very smart model with this very smart but slow and expansive model. And it's a great paper from Google, maybe a blog post, not a paper. I can't remember. There's too many switching between papers and blogs now. I forget. So yeah, it's a really interesting approach. The way I look at that is I look at that as a very effective, expensive kind of black box like LLM, which is to say, if you've got a very challenging problem, right, kind of a deep research style kind of question, I don't really care about the method that goes under the hood. I do from a technical perspective, I think it's interesting, but from a routing perspective, I don't care. If it's deep research kind of reinforcement learning kind of pattern, or if it's kind of this smart kind of cheap, fast exploration and expensive slow model approach. What that is certainly going to be on my routing curve is a very expensive model, and hopefully one with high quality. But I don't want to use that every time. That's a very bad thing to use every time. And so a router kind of can leverage that as it would any other LLM. And for prompts that really do require routing to this sort of approach, it'll route to this approach. Otherwise, give me a cheaper approach. That cheaper approach could just be a simple reasoning model, or it could be a very small specialized model, whatever it might be. So that is kind of how I view those approaches. I view them as kind of quite complementary in a way. And there is arguably some overlap, which is, they are doing kind of some intelligent kind of figuring out of when, how much time do I spend on this task? It's the same with, deep research. But fundamentally, kind of that is going to be slower always than a fine-tuned 7B parameter model for a specific use case, right? Which is just prompt, doesn't do any thinking, it just straight output. So I do think there's going to be this natural kind of complementary kind of behavior between the two. Hopefully that answers the question. Well. Mechan doesn't work for BrainShare, unfortunately. We'll get there.
Yeah, I was just since you said people couldn't read your mind yet.
Yeah. That's good.
Nice. Yeah, if you want to continue, otherwise I have infinite questions.
Yeah. Okay. So this was, I think I've in a way through the Q&A kind of answered, gone through what I wanted to with routing here, which was you can kind of set an operating point. So to achieve high quality, there's kind of the analogy you can get state-of-the-art performance, but you can also have considerable cost savings, right? I think people jump to cost savings first and don't necessarily think about you can get better quality, but kind of both can be true at the same time. You can get, if you think about a curve, you can get, compared to any single model, higher quality and lower cost. And yeah, so I think these are the basic concepts of judges and routing, kind of how we like to think about them. So yeah, I suppose that's kind of the meat of what I wanted to go through. So I'll kind of stop sharing now and kind of either hand back to you, or I can take further questions.
Let's we have some. If you have time, then we have time. It's always exciting
Yeah, I've got time.
to hear more. Any questions popping up in the chat? Very welcome. You're also welcome to raise your hand. Otherwise, thank you so much, Brad, for the overview here. And we can jump into even more Q&A. I think it's been a bit mixed now. We can route to the Q&A there. Nice. We have one question here. If you can speak more on model mapping and how it's done by Martian for routers.
By model mapping, is this referring to how, given a prompt, we select which model to go to?
I would assume so, yes.
Yes. Okay. Yes, I can share some more details on that.
Okay. It's the new interpretability framework called model mapping. Yes.
Oh, okay. In which case,
Sorry, that makes a lot of sense.
I may actually not be the best person to ask about this. I may have to follow that up with have one of our Mech-Inter researchers, PQ, follow up then if that is actually referring to something else, because I am not actually familiar with our approach there.
Yep. That makes sense. And of course, you can also chat in the discussion, Hack and Chat, and wherever other channels you want to chat with Philip and other
Yeah,
team members.
I would say, like, if you at his name should be in brackets PQ, but Philip, he will give you, I think, a great answer to that question. Better than I will butcher one there.
Yeah, he is wonderful. Nice. Nice. Yeah, in terms of the recent renaming as well, there was also with Philip and some of the teams here. It was a question of also making it more legible and understandable for mechanistic interpretability researchers, which I think is important to mention why this routing problem and these questions that are happening here are quite relevant for how mechanistic interpretability actually moves over to the real world, both making it safer and simpler and better. Yeah. So that is the answer to the questions for why the hackathon was recently renamed. Nice. I'm also curious, Brad. I am curious whether basically now there's a big business case. Obviously, for me, I am Ford Foundation or something. I evaluate 1 billion documents every single minute, and therefore I will save $30 million by using Martian, by routing it to the right models that are cheaper for the right tasks, right? This example you gave. What are like the next stages of this whole routing question? What are the next like beyond price? Where are you taking it in terms of both optimizing
Yeah.
pre curve, but then optimizing other pathways on the horizon?
So it's a good question. There's a few things. I showed you a plot of 2 dimensions of cost and quality. There are actually more dimensions if you think about this. What do you care about? Latency? What within latency? Do you care about time to first token? Do you care about throughput? Do you so those could be, you can combine them into one dimension. You could actually have now not a curve but a surface in 3 dimensions. And some models will have different latency requirements, but now it's not just models you care about, it's where are they hosted, right? And if you then put a 4th dimension of throughput on, it's now more interesting space again, because you might want to pick an operating point in this space and then move it about based upon if you've got an in-production use case, right? What do you care about happening at any point in time may change throughout the day in your use case. And you can imagine moving this operating point throughout the day. Maybe, on it's a I don't know if you know much about Facebook ads, but actually if you're on Instagram on New Year's Eve, you get worse ad recommendations on New Year's Eve uh, than you will at any other time of the year.
Hmm.
And that's because Facebook has to move a bunch of compute from ads, which they don't usually like doing, but to kind of core services such that they don't fail when everyone's messaging Happy New Year, right, to people, right? So what that means is, you still get ads, but the recommendations are just worse because they have to turn off a bunch of the, more compute intensive models. And so that's an example of kind of Facebook changing its operating point. And I know people who have like manually kind of on call who have been like, changing these things, like making sure things don't fall over. Far easier if you have kind of a control. And you can imagine like where this is going to be very useful. So, I've given you an idea of kind of a few different dimensions on kind of latency, but I think there's more as well. Like if you go into like the dimensions more on kind of like the more human kind of centered kind of things. Maybe at certain points of the day you want like more concise versus less concise, right? That can be a dimension, right? In routing, you care about moving, and especially if you're a business and you then want to optimize over that, you've got kind of meta optimization now. So kind of routing I view as kind of being an incredibly rich field. We are just touching the surface right now with kind of cost and quality. There's kind of so much more to do. So yeah, I'm really excited about the space.
Fantastic. And maybe a last question here from chat, and with a bit extra interest from here. From Diva, it's like, how do you see routing paradigm changes happening with agentic evaluation and like figuring out which models do the best calling? And then maybe as an extension to that question, I'm curious, basically like what I see here is a scalable framework for evaluating models on a range, a host of like a lot of different parameters, right? With the judges in general, agentic
Yeah.
evaluations being one of them, and evals as a whole field exists, and it's very difficult. And judging here is the way to solve some quite some relatively simplistic evaluation challenges regarding specific questions. Then I am curious. So you talk about, okay, two-dimensional, three-dimensional, four-dimensional, five-dimensional. Wait, what is this neural network thing we're talking about? These hyperdimensional models that go to a billion dimensions or whatever. Um, are you considering like foundation models for routing where I can just have a prompt and I'm like I care really much about this thing, price and this, and then it just like goes to the hyperdimensional space of yes, this is exactly the thing you want. And so you have all the dimensions are just different evaluation parameters, latency, accuracy, price, and then also whatever I care about really.
Yeah, it's an interesting question. I think you answered two questions actually. I'm gonna come and I'll do them in order. The first one you answered around was agentic workflows. So I'll discuss agentic workflows and what I view as kind of the future for routing in that world. My kind of short two-letter answer is RL, and my longer answer is this. So if you think about agentic workflows, you kind of have multi-turn conversations, and it can be conversations, but it can be also going out, performing an action, kind of coming back. Now we can look at that as we do right now, just as a simple kind of request coming in, response coming out. You can construct a data set and you can learn what is best to do based upon some judge, and you'll get something like which is functional and better than where you were before without routing. However, from a modeling perspective, it's subpar. It's subpar because you're looking at a local optimum solution here at each stage, and you actually care about the global optimum solution. And what that requires you to do in the learning process is to explore the space of opportunities. Now, this space is huge. And the good thing is, we've been working for the last, well, actually, I shouldn't say the last kind of, decade, but realistically, it's been going on for longer. But really kind of making a lot of progress recently on reinforcement learning techniques, which are perfectly adapted to this sort of problem. because what you care about doing is exploring the space. And it's the same problem they have with training reasoning models, right? You want really good RL folks in who understand how you can set up initial conditions well, how you set up the modeling process, how you can kind of go through and explore the space and update your parameters. So this is really how you get great routing and agentic workflows, is you look at it from, I think, the RL perspective, and you kind of explore that space and you train a router based upon the global solution. That requires a bit more effort and a bit more, investment kind of from us, but it's kind of the vision of where it wants to get to. We can do routing in the way we do right now. It's just and get better performance. It's just there's more room to be kind of to be had by looking at the RL kind of based approaches. Yes, Demis is the answer. Then going back then to your first question, which was actually your second question. I've actually forgotten what that was. I should have answered it there and then. What was that question again?
The first question from DY was on agentic evaluations and like tool calling as a parameter,
Yes.
given this paradigm change that's been happening in judging, I guess.
Yeah. So yeah, again, it's agentic workflows. I just really view as like you can do this right now in the current kind of setup. Your responses, right? I didn't say your responses are strings. They are chat completion responses. That can include tool use suggestions. And your judge takes in, those request and response objects. So that judge doesn't have to be acting upon the message part of the string. It can also act upon if it suggests a tool. And, so you can write judges that are looking at that information. You can write, routers that are, again, like extracting additional information from that request. Extracting whatever features it wants to make a prediction. So you absolutely like have full tool use functionality and can do everything you want with, I think, these abstractions of judges and routers in the way they're defined. What I was just emphasizing is I think to really get a good global optimum solution in agentic workflows specifically, which are not, it doesn't have to be tool use. It could just be chat conversations, multi-turn. That requires an RL approach to get a good global solution, which is where you get kind of further gains again.
Fantastic. Yes. So the judges are diverse enough to be able to capture that. Now,
Yeah.
maybe as a last question here, it's been a long talk. It's a good question, so that's what we're getting out here. Now Martian has, of course, invested in this like awesome Mechanistic team. And there's a bunch of exciting work happening across mechanistic interpretability. And maybe from your position, where you are at Martian, like how do you see this play into your future development? Is this exploratory? Is this something you already see actually improve how you work with these models? Is this something where mechanistic interpretability to you is like very exciting, very useful, immediately nice field that makes a lot of sense? Is it a place where you see just immense potential in the future, or something in between?
Yeah, it's a really great question. The founders of the company really view Mech and Terp as being very central to the company, and investing in this area. Like if we want to, build the best routers in the world, we've got to invest in Mech and Terp. That's non-negotiable. So, my perspective, I sit a little bit more on the machine learning side. So a bit more on the day-to-day kind of building good routers and judges. But I take as input mech interp research, right? Of course, traditional kind of ML knowledge and deep learning expertise, but also kind of the mech interp side. So if I want to build a judge which has low variance, I want to know why a judge has variance in the first place without having to just run it 10 times and then measuring it. So there's really interesting papers which can help us build tools, which is useful. For instance, I think there's a paper which is like, models know what they know. So if you want to know if a model's going to hallucinate or not, well, you can have the same parameters. You just switch off that final head to be a binary classifier. Are you going to get this right or not? and turns out they are very good at assessing that. So you you know there's a lot on the mech-interp side. There's of course steering. Like if you think about steering, like I said more models are better, right? What if you just had one model, right? And you just steered it in different directions and got different behaviors and had a router over that, right? That is a world of possibilities. Like you can, what we care about is not only like building a router with existing techniques, but like moving that curve up and to the left. And if that is done by the same modeling, but just by artificially making new points by some mech-interp research, that's amazing. That's super cool. So, steering is really useful to us, as well as understanding how they work. So if we understand how they work, we can of course, well, it's not necessarily like the next step, but it's, I think, a very logical argument to make that it means you can build better routers if you have a better understanding of how they work. So yeah, I view mech-interp as the same as the founders as being like pivotal to this whole kind of vision.
Nice. Yeah, that's the same for me for sure. I mean, it's it definitely turns out now that you need this sort of thing to do really exciting research here. Nice. Thank you so much, Brad. I'm really excited to see Martian do this work and sort of bring mechanistic interpretability into the real world where it can be useful to both companies and also to folks like us out here chopping together some papers to make sure it becomes even stronger and more reliable and verifiable and whatnot. And thank you so much for indulging in all the questions. Thanks to the audience for also joining us. And yeah, that'll be that. Thank you.
Yeah, thank you for the rich questions, everyone. I've really, yeah, really enjoyed the questions. There's been some good discussion.
Wonderful.